Hi everyone. Today we will solve this problem about moment of inertia. So we have a shape, I call that house, that is made of different shape that we know, triangle, rectangle, circles, half of a circles, all those shape we have the information for the mass moment of inertia and area in our formula sheet there. So the first step will be, let me try to do step by step. First steps will be to divide into usual shape, into usual shapes. Okay, let's do that. We will have a large rectangle. So we will have a large rectangle. That's the yellow one. We will have a small rectangle inside. Small rectangle. Don't forget that it will be a minus because it's a hole. So this one is, let's make it in blue. Can we draw blue inside on top? That's the blue inside. And we will have a triangle on the top here. Green, pink, so we can see it well. So that will be the first steps. Now the second steps will be to find the centroid of the global shape. So the C that we see there is the centroid of the global shape, and the goal is to find the mass moment of inertia about this axis x prime. Okay, so about an axis that is parallel to x, but is going through the centroid of this usual shape. So let's find the y bar, that this distance there from x on the bottom. Okay, we need to find the y bar. So what we need to do, we need to find the y tilde. We will use the formula that say that y bar equal the y tilde of each shape times the area divided by the sum of the area. So we will have rectangle 1, rectangle 2, triangle, and what we need, the y tilde. Let me move this a little bit down so we have enough space. So we will have here the white tilde. Here we will have the area. And there the y tilde times the area. We will not need also the total area and the total y tilde A. Okay, so let's fill this table one by one. First, the large rectangle. Oops, it should be yellow. Here we go. So this white rectangle, the y tilde will be in the middle. Okay, so we have this yellow rectangle. The 8 is 450 and the side is 300. So the y tilde is at 450 divided by 2, so 225. Okay, so 225. The area will be the 450 times 300. And after that, the y tilde times a, that will be the multiplication of both of them. And I have 135,000. Okay, you can keep everything in millimeter. That doesn't matter. As soon as you keep your units all the same, you will get the y tilde in millimeters too. So that was for the rectangle 1. Now for the rectangle 2, let me draw it there. In the center, this is the little one. How long is it? It's 400 minus the bottom there. So it will be 350 for the 8. And the inside, it will be 300 minus twice the 50. So that will be 200. Okay. And now for the distance, don't forget that you want the y tilde from the same axis, from x. We want to use the same reference. So that will be the same middle than the large rectangle. That will be 225. And the area will be then 350 times 200. And when we do multiplications of both of them, that will be 70,000 1000. And don't forget this one, I will put it in minus. That will be, oops, I will put it in red. That will be a minus, and that will be a minus because it's a hole. So we want to remove this area, and we want to remove the y tilde A. Okay? And now the triangle. So the triangle, it's on the top there, like this. Okay? I like to draw them again. 300 for the base, 240 for the 8. Okay, and don't forget, we want the same datum again. And so we want to have this distance for the y tilde. So that will be the 450 plus 1/3 of 250, of 240. Oops, let me clean that. Okay, so just be careful because, so 1/3 because it's from the base, so 1/3 from the base or 2/3 from the top. And we always want the same datum. Okay, always want the same datum, so it's from the bottom. So we need to add the 450, that is the 8 of the large rectangles, plus the 1/3 of that. So 450 plus 1/3 of 240, that's 530. Okay, the area, that would be 300 times 240 divided by 2. And when we do the multiplication of this, we got 36,000. Okay? So now we do plus, plus, plus. Like for the total there, that will be A1, the minus the A2 plus the A3. We get for the total area 101,000. That's millimeter square. And for the total y tilde, do I have this data? I don't think I have this data. Let me do it. Okay. Oh, I think I didn't stop. So I was finding the value for this. It's a long value. It's 33,705,000. And so this is the sum of the y tilde A. And at the end, we find y bar, that is equal to the 33,705,000 divided by 101,000. And that gives us 333.7 millimeter. Okay, and we need to check, does that make sense? Oops. Does this answer make sense? The y bar, that will put the value, let me clean what I drew on this. That will give us a y bar of 333.7 millimeter. So we was 450 the total, 8 of the large rectangle. So I think that makes sense. That's kind of a little bit higher than the 225. It's below the 400. So the way it's drawn on the picture, it makes sense. That was our first step. We found the, oops, let me just put the colors. Here we go. We found the location of the centroid of the global shape. Now we need to find the third. Oops. Why does that right? Oh, I know why. We need to find the MOI about x bar. So what is the x prime? Sorry, x prime, or about this axis. So what is the formula that we use? We use the theorem of parallel axes, theorem. For all of them. And the theorem tells us that the I at x prime will be equal to the I at the C and at the centroid for each shape plus distance square times A. Okay, so we can prepare a table with, here we go. We can prepare a table. What we will have? We will have rectangle 1, rectangle 2, and triangle. what we need for the IC. So depending on the IC, the formula are there. So the formula are, oops, let's square them. We want them about x, right? This one. So that will be the 112 of BH cube. And we will want this one that is parallel to the x prime. That is the 1 divided by 36 BH cube. So we will have one there and one in the middle, two in the middle. Okay. What do we need for those formula? We need B and H cube. We will need a lot of information. So we can have in the table, I'm sorry, I'm keep clicking on it. We will need B. We will need H. We will need the distance D. That will be the centroid minus the y bar. That will give us the D. And we will need the A for this one. And at the end, we will have the x prime. Okay, I know it's a lot of data, but let's try to be organized. Let me grab the ruler. Up. Draw. Oops. I don't know why it keep removing me some space on the bottom. Okay, let's do one step at a time. Okay, let's me. Okay, I managed the bottom. So for the rectangle 1, this one, the B, super important to keep our drawing there. So the B is 300 and the 8 is 450. Okay. So let's add one more step. And so the I about C in this case will be 112 of 300, the base time H cube, this one there, H cube, time 450 cube. For the rectangle 2, we have it there, we have it this one. It's 200 for the base, 350 for the 8, so that will be 112 of 200 times 350 cube. It's a 5. Okay. And for the triangle, the base is 300. The 8 is 240. And just be careful because for the triangle, this is 1 divided by 36 times the base, so 300 times 240 cube. Here we go. So we have the IC of each shape. Now we need the distance and also the area. We have the area on the top, but let's try it too. So the distance D, that will be the centroid of the shape minus the centroid of the global shape. So the centroid of each shape, let's call that the C tilde or the Y tilde. We found them before. That was 225, 225, and 430. Okay. The Y bar is the same for all of them. So that the 333.7, 333.7, and 333.7. So the distance D, that will be this Y tilde minus Y bar. Okay. And that will be 108.7, 108.7. And the last one is 196.3. And yeah, if we do, I didn't count the distance, but that doesn't matter. Okay, there is a minus there, but remember that we take the D square. Okay, after that. So if you want, you can add one more column with the D square. And we will need the A. I know it's longer than I thought because I really make one step at a time. Oops. Okay. So the D squared, that will be the 108.7 square, 108.7 square, and 196.3 square. Okay. Just don't forget the square. I think this step is important because I see a lot of mistake with this square that disappears somewhere in the formula. Okay, so we have the IC there. We have the distance d square there. We need the area, and you can grab the data from the previous table. So 450 times 300. I recommend do not put the minus for the area right now, okay? Because the minus will apply to the IC and to the d square A. So let's keep it plus. So 350 times 200. And I'm looking at this table there, at the A there. 300, oops. The 300 times 240 divided by 2. Okay, and now I can find the x prime. And what you do IC plus d squared times A. And you use this value, this one, this one, this one, this one, this one, and this one, this one, and this one. Okay, I will just write the total value. That's very long value. I will use them with the scientific formula. Okay, so 1, 2, 3, 4, 5. So 3.87 times 10 at the 9. 1.54 times 10 at the 9. And 1.502 times 10 at the 9. Here we go. Just note, I added a big minus in front of this one because that's a all. So at the end, your x prime will be 3.87 times 10 at the 9 minus 154 times 10 at the 9 plus 1.502 times 10 at the 9. So your x prime will be 3.834 times 10 at the 9, and it's millimeter fourth. You can keep it in millimeter fourth. And that's it. So I will say, and if you want to find the radius of gyrations in your homework, you need to find the radius. You do k equal, so that will be k about x prime, will be the square root of the x prime divided by a. So that will be this one, 3.834 times 10 at the 9 divided by this area there. Oops, 101.00, and that will give us with that. Oh, I don't have the value. Let me find it. Okay, SQRT of this divided by the total area. Here we go there. 194.8 millimeter. And your radius of gyrations, it should be like, we have a shape like this. Okay, we have the x prime in the middle. This distance, that's the radius of gyrations. That cannot be more than this distance. Okay, that represents how spread is the area around the axis x prime. It should be somewhere in between the center and the bottom of your drawing. Okay, your area is not spread more than that. It's somewhere around this axis. So this distance, the total distance that was, so this one is 300 333.7 millimeter. So the K, it's about 200 inside. That makes sense. Okay. So yeah, that's it for those steps for what you call the rocket and what I call the house. And that's very helpful steps for your homework too. Hope that helps. Bye-bye.